Hello everyone and welcome to your Chem 113 review on wavelength and frequency. My name is Jason and I work for the ASU Tutoring Centers. As I mentioned in the previous video, wavelength and frequency are pretty much inversely proportional to one another. As you increase wavelength, you decrease frequency and vice versa. So if you haven't seen the previous video on electromagnetic radiation, I definitely recommend checking that out. I did a quick overview of wavelength versus frequency. In this video, I'm going to talk about probably the most famous equation that relates wavelength and frequency. And that equation is C equals lambda nu. Nu is like a Greek letter. It looks kind of like a V. I draw it like that. I've seen it drawn like that. It's basically like a V. What each of these things means. So C is the speed of light. So very, very famously, light has sort of a speed that it travels at. You know, there's slight variance in it depending on what medium it's going through, whether it's, light traveling through water, or light traveling through air, or light traveling through the vacuum of space. But as a whole, light always travels at a constant speed of 3.00 times 10 to the 8th meters per second. That is light speed. All light travels that fast. Nothing can travel faster than that. Nothing in the universe travels faster than light. At least that we currently know of. Ooh. Okay, so that's the speed of light. Lambda, that's the common symbol used for wavelength. And nu, that's the common symbol used for frequency. Now, the thing about wavelength is often measured in nanometers. And frequency is often measured in inverse seconds. So 1 over seconds, or seconds to the -1 power. We have to be a little careful of this though, because especially if we're using the speed of light as 3.00 times 10 to the 8th meters per second, we need to be careful with using meters here, but using nanometers here. We're gonna have to do some unit conversions in this equation. Okay, so in our particular equation, we are told we have this yellow light that has a wavelength of 589 nanometers. We have lambda equals 589 nanometers. What is the frequency? So we want to try to find nu. So using this equation, we can solve for nu. We divide the lambda over, and we get that. So then, we're plugging in our value for the speed of light, dividing by the value for the wavelength. And then we have to be careful here, right? We have meters up here and nanometers down here, so they don't exactly cancel. What we'd have to do is convert these nanometers into meters. What is the conversion for that again? Well, 1 meter contains 10 to the 9th nanometers. Nano is a very, very common prefix in chemistry, particularly because light is really small. The wavelength of light is really small. It's usually measured in nanometers. So if we convert these nanometers to meters, we realize that the nms cancel out and the meters cancel out. So our units will be 1 over seconds, which is the exact unit of frequency. So then doing the 3.0 times 10 to the 8th divided by 589 times 10 to the 9th gives us a value of 5.09 times 10 to the 14th inverse seconds. That is the value of the frequency for this yellow light that we have. Okay. All right. Well, thank you for watching. As I mentioned, I work at the tutoring centers on campus. If you want more information about the free tutoring services available to you on all 4 major ASU campuses and online, check out tutoring.asu.edu/content/tutor-search. Here you'll be able to find a tutor on your campus or online that'll be able to help you with your specific class. Thank you again for watching, and I hope you have a wonderful day.